Hello and welcome to this session. This video is especially for mathematics. Graphs of quadratic expression, graphs of ax square plus bx plus c. Okay, just understand that ax square plus bx plus c is an expression, and you can find the graph of this expression. You cannot find the graph of this quadratic equation, because quadratic, when it becomes equation, it will give you two roots. Okay, and when there will be two roots, how can you draw? So you will draw the graph for expression, not for equation. Just keep it in mind. So ax square plus bx plus c. Let's see what will be the nature of graph when a greater than 0. Okay, so with a greater than 0 there are some cases. Okay, some cases like will be that it is a plane, x axis is there, x dash, y dash. Okay, so now when a greater than 0, then the graph of ax square plus bx plus c will be upward parabolic. It will be how much? It will be how look like it? So it will look like an upward parabolic, like this, okay, or like this, or like this. From here it will become, or like this here. Okay, or simply it might touch the x-axis. Okay, it might touch, but all these things shows the conditions. When it will touches the x-axis, when it will intersect the x-axis. Okay, so it means what? You have understood the nature that when a will be greater than 0, the graph will be upward parabolic. So upward parabolic it will be. Listen, here I am going to make you understand it. So it will be like this. When it will be like this, it is just touching the x-axis. It means just touches the x-axis. It means the value of, this is origin, the value of x, suppose here it is x equal to alpha, then there is one and only one root here, or you can say two roots but at the same point. Okay, it means alpha bara equal to beta. Simple. And this location is this. So what does it mean? A greater than 0 and d equal to 0. D equal to 0. When d equal to 0, then roots are equal. Okay, and at that time the parabola will simply touch the x-axis. Okay. Similarly, in the second scenario, when a will be less than 0 but d equal to 0, what would happen? It will simply go downward parabolic and touches the x-axis. Okay, only one root be here, or two roots you can say, but they are equal. But it will be downward parabolic because a is less than 0. So whenever a is negative, it means coefficient of x square is negative, the graph will be downward parabolic. And whenever the coefficient of x, it means a greater than 0, the graph will be upward parabolic. And now some cases d equal to 0, then upward parabolic but touches the x-axis at any point. D equal to 0, in the case of a less than 0, it will touch the x-axis like this. It can touch x-axis like this also. Okay, and in this case it can touch it like this also. There is no problem in it. Okay, so this case you have understood. Now the next thing is what? The next thing is, suppose a greater than 0 and moreover d is also greater than 0. Okay, the second case is a less than 0 and d greater than 0. What would happen? Okay, so let's see the graph and its nature. So it will be like this. So when in the first case a greater than 0, the graph will be upward parabolic, you know very well. D greater than 0, when d greater than 0, then there will be two distinct roots, two different roots. Okay, and if d is perfect square, then alpha and beta will be rational or integral. Okay, but when D not a perfect square, then alpha and beta means the two roots will be conjugate and they will be irrational. So suppose the graph is going like this. Okay, the graph is going like this. So this will become one place, let's say alpha, and this will become other place, let's say beta. Okay, so in this case the graph will be like this, and in this case the graph will be something like this. Okay, let's say here is some point gamma, here is some point delta. Okay, so it is downward, upward, vertically, the parabolic downward. Okay, why parabolic downward? Because a is less than 0, and since d greater than 0, therefore it will intersect the x-axis at two distinct points. Similarly here, it has intersected the x-axis at two distinct points, and these two distinct points are the roots of the equation ax square plus bx plus c equal to 0. Okay, this graph is for this expression ax square plus bx plus c, but these points, it means the roots are for the equation ax square plus bx plus c equal to 0. Just keep it in mind. It is very imperative to understand. So let's proceed. Now let's understand the third case. What is the third case? The third case is when a greater than 0 but d less than 0 and a, you can understand that a greater than 0, so parabola will be upward, there is no doubt in it. It might be like this, whatever, open mouthed, upward. Okay, but d less than 0, and I have just taught you that when d less than 0, roots are imaginary. It means you cannot find any point on the x-axis to represent the imaginary roots. Got it? You cannot find any point on the x-axis because it's not real, it's imaginary. So the graph will be like this, something like this. Okay, it will never touch x-axis. Okay, or like this. It will never touch x-axis in the case when a greater than 0 but d less than 0. It might be like this also. Okay, but in all the cases the graph is not going to hit the x-axis. Keep it in mind. In the second case when a is less than 0 but d is less than 0 also, so what would happen? Simple. A is less than 0, downward, and since d is less than 0, so in the same graph I am going to teach you, it will be like this. Will not touch x-axis anywhere. Will not touch x-axis. Will not touch x-axis anywhere. Okay, got it? And downward parabolic. So these are the three main cases in the graph that I wanted to share with you. But some derivation right now I'm of a quadratic expression. You can understand it because the topic is related to pertaining to quadratic equation, quadratic expression. Therefore, I am going to find out minima and maxima. What are minima and maxima? Minima means minimum value of the quadratic expression at some particular point. Maxima is maximum value of that quadratic expression at some particular point. Okay, so let's see that how we can derive it, how we can find it. Graphically, I want to teach you because graphical method is very much easy to understand and very much easy to decode it. So let's suppose ax square plus bx plus c is a quadratic expression and its corresponding equation is ax square plus bx plus c equal to 0. Okay, now we have to consider two things that you know very well that a will not be equal to 0. So a will not be equal to 0. So what will be a? A might be greater than 0, or a might be less than 0, or a might be equal to 0. But the third case, a equal to 0, is not acceptable in the case of quadratic expression. So either it will be greater than 0 or it will be less than 0. Okay. So I am going to teach you that you understood very well that alpha plus beta is minus b upon a. Okay. Alpha into beta equal to c upon a. Let it go. Just see, in the first case, when a greater than 0, when a greater than 0, when a greater than 0, this is the first case I am going to teach how to find the maxima and minima. Okay, so a greater than 0, then what would happen? Just see. The graph will something like this. Yes, upward parabolic, upward parabolic. So if it will be upward parabolic, it means here will be some root alpha and here will be other root beta. So there you are going to find its minima, because the minimum value you can find here, and here which point we say minima. Just try to understand. Suppose here a tangent is like this, here a tangent is parallel to x-axis, and here a tangent is like this. It means what? This graph is coming down here, and from here it going to start rising. So when it will start rising, it going to upper side, it coming to downside. So at that point where it just changes its nature, coming to down and going upward, then that point is the point of minima. This is the point of minima. It means the minimum value of this graph you can find. And what about maximum value? So maximum value will be infinity. It means whatever value you can assume. Okay, it might go into infinity. Okay, so the minimum value will be here. It can be found out, but maximum value will not be found out exactly, because that is going to be infinity. So how to find this minimum value and how to find this maximum value? This is the question. So here the second case also I want to just depict it in the sense here on the same graph, like this will become when a less than 0, this will be downward parabola, and when it will be downward parabola at this point, and the midpoint here, it will be the point of maxima. Point of maxima. And here it is the point of minima. Okay, just keep it in mind and very easy to find it out. Let's say here we start. Let's say it is also alpha dash and beta dash. This is alpha theta. Okay, so you know very well that alpha plus beta is what? Alpha plus beta is what? Is equal to minus b upon a. Good. So you can see that the average of alpha and beta will be the midpoint on this axis, and this midpoint where it touches the graph will be the point of minima in this case. And again alpha dash beta dash, the midpoint will take as alpha dash plus beta dash upon 2, and where it touches the graph, that point will be the point of maxima. Keep it in mind. So what is this? This is alpha dash plus beta dash by 2, and this is alpha plus beta by 2. So now alpha plus beta equal to minus b by a. So what will be alpha plus beta by 2? It will be minus b by 2a. Okay, so this point is going to be, you know, the x coordinate of this point is going to be minus b by 2a, and y coordinate will be 0 because it's on x axis. But what about the coordinate of this point, the maximum point, sorry, the minimum point? So let's say this point is p, its x point is also minus b upon 2a, and what about its y point? It means what about its, you know, this graph, you know, x point is here, x coordinate is here, what about its y coordinate? So this is very interesting to find out. Similarly, here you can find x as minus b upon 2a once again, if I am talking about the same quadratic expression with different conditions. Okay, so this will once again will become minus b by 2a comma what? Okay, this what we have to just put. Okay, so let's derive it. You know, This point minus b by 2a is the value of x which lies on the graph given by x square plus bx plus c. Let's say the graph is px equal to ax square plus bx plus c. Okay, this is quadratic expression. And when you will put the value of x as p minus b by 2a, here the x coordinate is minus b by 2a, put b x equal to minus b by 2a, it will become a into minus b by 2a the whole square plus b minus b by 2a plus c. Okay, and from here it is going to become minus b square minus 4ac upon 4a. When you will solve it, you will find the exact value here what I have written. So, my dear students, minus b square minus 4ac. You know very well that b square minus 4ac is discriminant d. So, if it is equivalent to d, you can write it as minus d upon 4a. Yes. So, at the point minus b by 2a, when x coordinate is minus b by 2a, the y coordinate will be minus d by 4a. Similarly here, y coordinate will be minus d by 4a, and this value minus d by 4a is the value of minima here, in this case upward parabola, and this the same value minus d by 4a is the point of maximum value, in this case when the parabola is downward. It means the graph is downward, and when the graph is downward, you know very well, a greater than 0, then graph is upward, and this case is when a less than 0. Both the case I have represented in the same graph. Okay, so don't confuse here. Take it easy. I hope you all guys are understanding it very well.